The update command can be used to change data in a relation. The syntax of the command is straightforward. We explicitly need to list changes for each field in an updated statement and separated by a comma. The where clause is optional. The syntax of the where clause is identical to the where clause in SQL query statements you are familiar with. It is very important to note that the update statement is applied to all records in the named relation if the where clause is absent. That is, all records are affected by the update statement. If we want to change only qualified records in the relation, we must use the where clause to provide the logical expression as a filter to select records to apply the changes. I want to offer one tip on reducing the chance of making incorrect changes. I always write a SQL query to retrieve the rows I want to make the changes. After being satisfied with the results, I then copy the where clause of the query statement to my update statement to assure that only those qualified records are changed. Note that the data would raise an error message if the update would violate the data integrity. For example, changing the value of a primary key field to null. It is because primary key fields cannot allow null values, i.e., the entity integrity rule. The change would result in a violation of the referential integrity constraints we just discussed. Here are some examples using the update statements. All those examples change the local field in the student relation. You should examine all those update statements carefully and answer the question, what rows did each update statement modify? That is, what rows are affected by each update statement? You should also explain your answer. The delete command is used to clear all data in a relation. The syntax of the delete statement is rather simple. Like the update command, the where clause is optional. If we want to delete specific records from a relation, we must write the logical expression to filter out the records to be affected by the delete statement. If the where clause is not provided, all records will be deleted. That is, all data in the relation would be cleared out. Take a close look at those two delete examples and answer the question, how many rows were deleted by each delete statement? Explain your answer. Note that the deletion statement would fail and cause an error message if we tried to clear the data which have foreign key references. To resolve the error, we must remember to clear all foreign key references before clearing primary key values. The SQL drop table removes a relation from the database. You have used this command in the previous class assignments. The syntax is very simple. Ruining a SQL delete statement resulted in deleting both the data and the relation. We must remember to delete all foreign key references before dropping the relation containing the reference primary key. That is, the order of deleting relations matter. Let's use the university database design example to illustrate how to determine the order of deleting relations. The order to delete relations are the opposite of the order to create relations, which we discussed earlier in this session. First, we delete those relations that were not referenced by any foreign key. In our example, this group includes advisor phone, student phone, person phone, advisory, enrollment, student program, and program course. Second, the next group should include those relations whose foreign keys referenced only those relations just being deleted in the first step. In this example, this group includes advisor, student, instructor, program, and class. Repeat the second step above to identify the next group of relations to be deleted. The third group includes department and course. Repeat the second bulletin above again to identify the fourth group of relations to be deleted. This group has only one relation, college. Note that the order to delete which relation within the same group does not matter. That is, relations in a group can be deleted in any order within the same group. Creating an index on a relation improves the data retrieval performance. The concept index is like the old telephone book that sorted phone numbers alphabetically by categories like commercial telephone numbers and residential telephone numbers. The phone book speeds up looking up specific phone numbers without having to search all telephone numbers. Similarly, an index on a field can create a sorted value list of that field. Since all values of that field are sorted, SQL queries using that field in the where clause of a SQL query statement can improve the performance. In the example on this slide, we create an index on the last name field of the student relation. By default, the database creates only a default index on the primary key field. The last name field is not a primary key field, and the names are not sorted in any order. As we know, querying students by last name is commonly used in database queries. Creating the index on the last name in alphabetical order can help improve the performance. For example, let's assume that we want to retrieve students whose last names before the letter H, like Hansley. Using the last name index, the database can stop the search at the next student record whose last name begins with the letter H. That is, the last names of all remaining student records are not qualified. That is, we improved the query performance. Note that an index may be created on a single field or multiple fields. The outcome of the index is like that of the sort by clause in database query statements. It is very important to drop index on a relation before deleting the relation. Otherwise, the database would raise an error. Interact with ChatGPT to understand the create index command. Here are example prompts. I am learning SQL in my college database class. Could you explain the SQL create index command? What does it do and why are index fields needed? Could you show me some examples to help me understand? After reading the response, you should ask for explanations and examples of new concepts mentioned in ChatGPT's response. Summary. Business rules dictate the design of data integrity constraints. The physical design of a relation must define all attributes, attribute data types, required fields, and other data constraints. Primary keys, foreign keys, and referential integrity constraints. Need to understand how the constraints are enforced by DBMS. The support of constraints varies with DBMS, for example, SQL Server and MySQL fully supported. Oracle does not support the onUpdate constraint. SQL commands summary. This session covered the following SQL DDL commands. Create table, drop table. Create index, drop index. And those SQL DML commands. Insert, update, delete. Not covered SQL commands. This session did not cover the following SQL commands. Create view to be covered in SQL queries. Alter table, insert select, update select, merge, truncate table. Creating database instances, a task usually done by database administrator, DBA. Creating triggers and stored procedures/functions, a task usually done by application developers or DBAs. Refer to vendor manuals for supported and extended SQL commands. With that, we conclude the discussions about physical database design. Thank you very much for watching the videos.